Hey everyone, in today's video we will go over the implementation for random forest in Python. Random forest is a machine learning algorithm that belongs to the ensemble learning family and is based on the Bayesian technique. It is used for both classification and regression tasks. The algorithm creates multiple decision trees during training and combines their outputs to make predictions. Random forests offer several advantages. Reduced overfitting. By creating multiple trees with different subsets of data and features, the algorithm reduces the risk of overfitting compared to a single decision tree. Robustness. Random forests are less sensitive to outliers and noisy data due to the aggregation of multiple trees. Feature importance. The algorithm provides a measure of feature importance, indicating which features contribute more to the prediction. Nonlinearity. Random forests can capture complex nonlinear relationships in the data. Okay, so the first step is to import the relevant Python libraries. So we need OS, math, NumPy, pandas, and model selection from sklearn. The first class that we have is leaf. This is the most basic object that we have in our case. The predict function of a leaf is simply returning the value inside that leaf. Next, we have node class, which defines one node in the tree. So the init function sets the level of the node in the tree. The split feature, which we will later see how to calculate, the split value, the left node, and the right node, which could be either a node or a leaf. The node predict function gets a row that contains a sample feature and checks that if the row value of the split feature is bigger or equals to the split value. If it is, the predict function returns the right node prediction, else it returns the left node. Now that we define the two base objects, we can now move on to the decision tree classifier. This is relatively a large class, so I will go over each function and explain. The init function gets a max depth that defines the max depth of a tree, and it also sets a root to be none for now. Next, we have the setRoot function that sets a node to be the tree root if the root is null. The class count function returns for each unique number in Y is number of appearances. So we use here the NumPy function unique and return the values and their counts. Now the function calcPopular class returns the most popular class in a set of labels. So first we get the class count, and then using the argmax function we can get the counts max value index, and using that index we can get the class value. Okay, moving on to the calc-Gini function. So Gini score is the metric we use to evaluate the impurity of a set of samples within a particular node of a tree. Or in other words, this is how we check how good a split is. So first we get the class counts and divide each value count by the number of samples. Once we have the class probabilities, we can calculate the Gini score with the formula of 1 minus the sum of all probabilities powered by 2. Now, the function features to check gets the number of features and returns indexes in that range. In the function best split, instead of checking all possible features, we check only some of them that we choose randomly, and it's acceptable to choose the square root of the number of features. So we get the square root of the number of features, then we generate some random numbers in that range and return them. The function getBestSplit returns the best split for the given data. First, we set some variables. We have the number of features, the rows number, best split feature, and best split value that are both set to be 0 for now, and the best Gini that right now is 1. Now we call the function features to check and get the indexes of the features that we are going to go over. So for each feature, we take all the unique values in the data of that feature, and for each value, we split the data. So as you can see, the data split function just splits the data by feature and value. So all the values in that feature that are bigger or equal to that value are going to be in the right subtree. Otherwise, they are going to be in the left one. So back to this function, after calling the data split function, we have the right rows, right labels, left rows, and left labels. Now we check if the split was good by calculating the average Gini. So first we calculate P, that is the number of rows in the right subtree divided by the number of rows. This will be the percentage of the rows in the right subtree. Now the average Gini is equal to P multiplied by the Gini score of the right subtree divided by the number of rows plus 1 minus P multiplied by the Gini score of the left subtree divided by the number of rows. Now we check if the average Gini is smaller than the best Gini we set at the beginning. If it is, we set the best Gini to be the average Gini and set the best split feature and best split value to the feature and value that we just found. Eventually, the function returns the best split it found for this data by returning the best split feature, best split value, and the best Gini. Now the next function is the fit function that gets x and y and build the tree by setting the root of the tree with the split node function. The split node function is a recursive function that sets the nodes of the tree. So first we increase the node level by 1. Then we have the first stop condition of the recursive function. In that, we check if the length of y is 1. If it is, we set a leaf with the value of that class. If not, we call the getBestSplit function and get a split feature, split value, and Gini score. Then in stop condition number 2, we check if the Gini score is 0 or if we reach the max depth of the tree. In this case, we calculate the popular class in y and set a leaf to be that value. If it didn't stop here, we split the data according to the feature and value that we got earlier and get a right subtree and a left subtree. Then we check if the number of labels in the right subtree is 1. We set a leaf to be with that value, else we check the same thing for the left subtree. If the function didn't stop here, we go and continue splitting the tree even further. Then, at the end, the function returns a node object with the node level, the split feature and value, and the right and left nodes. After that, we have the predict function that predicts for each row in a test set its class, and we also have an accuracy function. So that was it for the decision tree class. Now let's go over the random forest class. The first function that we have is the create subsample function that returns subsample of size n tag of the dataset. N tag is A multiplied n, the number of samples in the dataset. So we initial n and the n tag, and then we choose random samples indexes in the size of n tags, and then just return this subset. Now, the fit function builds the forest. The T parameter is the number of trees in the forest, and the max depth is the maximum depth of each tree. So we go over the trees, and for each one of them, we create a subsample of data, create a decision tree, fit it on this subset, and add it to the forest list. By the end of this function, we will have a list of decision trees that each one of them was trained on only some of the dataset. Now the next function, calcPopular class, gets an array of classes y and returns the most popular class in that array. Now the BeginPredict function predicts for each row in the test set its class by getting all trees predictions and then setting the most popular class as the predicted class for this row. Now let's test the model on some data. So this time I'm going to use the breast cancer dataset. I'm not going to explain and process the data because this is not the purpose of this video. So we're just going to split the data into train and test sets and define the random forest model and fit it on the training data. And then we are going to get the predictions for the validation set and print the accuracy. And that's it for today's video. Thanks for watching.